Hello friends, I am back with the atomic structure part 3 lecture. Myself Vedanta Kumar Bora, Associate Professor, Department of Chemical Sciences, DR College, Assam, India. So before this, I have presented you with 2 video lectures in the atomic structure series, part 1 and part 2. In the part 1 of the lecture, I discussed regarding the discovery of the subatomic particles, namely electron, proton, and neutron. And in my second lecture, that is atomic structure part 2, there I discussed Rutherford's scattering experiment and Planck's quantum theory. So step by step, people were curious and new ideas crept into the mind of the physicist and chemist, and their belief regarding the structure of atom changed. So today we'll be delivering the part 3 lecture of atomic structure, and in this lecture I'll be discussing the photoelectric effect and Bohr's theory of hydrogen atom, and also Bohr's explanation of hydrogen spectrum. So if you have any query, you can email to me in my mailing address, that is vedanto69@gmail.com, and I'll be happy to clear any doubt in your mind. So let us go to the PowerPoint, that is the part 3 lecture. So here I am with atomic structure part 3 lecture. So now we will go to the main slides. So already we know that atom is made up of electron, proton, and neutron. Both electron and proton, it was discovered by Sir J.J. Thomson from cathode ray experiment, that with normal cathode and with perforated cathode. Then neutron was discovered way back in 1932 by James Chadwick. So people were curious to know how do these subatomic particles make up atom. Now before proceeding to the other slides, so first of all I would like to give you some information regarding what is called atomic number, what is called mass number, etc. Now atomic number, it is represented by Ch, and it represents the number of protons present in the nucleus of an atom or an ion. So till now what we have learned, that atom comprises of nucleus, and nucleus is positively charged. That means protons are present in the nucleus and electrons revolve around the nucleus. So the number of protons which are present in the nucleus of an atom or an ion is called its atomic number. In case of an atom, it is electrically neutral. That means the number of proton is equal to the number of electrons. But in case of ion, the number of electrons and number of protons is not same. So for an anion, we'll have more number of electrons than its atomic number, and for a cation, we'll have less number of electrons than its atomic number. And for atom, the number of electron will be also equal to its atomic number, that is equal to the number of protons. Then what is mass number? Mass number is defined as the number of protons and the number of neutrons present in the nucleus. So mass number is equal to atomic number, which is the number of protons, and it is equal to the number of neutrons. Now we have to understand what is the meaning of isotope. We already have discussed what are atoms. Atoms are the smallest indivisible particle of element, and each atom is made up of electron, proton, and neutron. Now, what are isotopes? Isotopes are atoms of the same element, but they have different number of neutrons in the nucleus. That means isotopes, they are atoms of same element. That means they have got same atomic number, but they have different number of neutrons in the nucleus. That means isotope will have different mass number. So isotopes, in simple words, they are atoms of the same element, but with different mass number. And the mass number is different because isotope have different number of neutrons present in their nucleus. So this is an atom of an element X. Z, it represents the atomic number, and A represents the mass number. So this is the general way of representing atomic number and mass number. Atomic number, it is a prefix in the lower, in the left hand side, and it is subscript, and the mass number is the superscript, and it is represented by A. So X represents the symbol of the element. Mass number, atomic number. So here there are three isotopes of hydrogen represented as 1H1. This 1H1, it is commonly called protium, or commonly call it as a hydrogen. 1H2, that is atomic number 1, mass number 2, it is commonly called deuterium, or it is also called heavy hydrogen. And 1H3, atomic number 3, mass number 3, atomic number 1, mass number 3, and it is commonly called tritium. So hydrogen, they are atoms of the same element, protium, deuterium, and tritium. They are elements, atoms of the same element, so they have got the same atomic number, because atoms of the same element will have same atomic number, but their mass number is different because they contain different number of neutrons. So in case of protium, atomic number is 1, mass number 1, that means there is no neutrons in the nucleus. And for deuterium, atomic number is 1, mass number is 2, means in nucleus of deuterium there is 1 proton and 1 neutron, and here there are 1 proton and 2 neutrons. So protium, deuterium, and tritium, they have same atomic number, but they have different mass number because they have different number of neutrons in their nucleus. So protium, they have no neutron, deuterium there is 1 neutron, and tritium there is 2 neutrons. Then again, these are the isotopes of uranium. So both are the atoms of uranium. They have same atomic number, but the mass number is different because they have different number of neutrons present in their nucleus. So since these are atoms, so mass atomic number is 92. That means number of proton is 92. Number of electron is also 92, but the mass number will be higher than 92. So it is 235. Because 92 into 2, it should be 184. So here mass number is 235. That means you have 35 plus 16, 45, 51 extra neutron. Here also there will be more number of neutrons. So these are the isotopes of uranium. Then these are the isotopes of carbon. This is carbon 12. Atomic number 6. That means number of proton 6, number of electron 6. Mass number is 12, so number of neutron is 6. So number of protons and number of neutron, it is equal to 12. That is the mass number. Carbon 13, mass number is 13. So there are 6 proton and 7 neutron. And carbon 14, it is the heaviest isotope of carbon. Mass number is 14. So there are 6 proton and 8 neutrons. So I hope this is clear to you all. So isotopes, they are atoms of different elements which have same mass number, and isotopes have different number of neutrons in their atoms. Then there are 2 other similar terms, what is called the isobar. And what are isobar? Just opposite of isotope. They're atoms of different elements, but they have same mass number. Atoms of different element means they have different atomic number, but they have same mass number. So there are two examples, 6 carbon 14 and 7 nitrogen 14. So you see 6 carbon 14 is an atom of carbon and 7 nitrogen 14 is an atom of nitrogen. They have got the same mass number. So if atomic numbers are same, different, that means their atoms are different element, but they have same mass number, they are called isotopes. Similarly, we have isotopes of magnesium and sodium. They are called isobar because they also have same mass number. So mass number is 24. Here mass number is also 24, and they are isotopes of magnesium and isotope of sodium. So I think it is clear to you what is isotope and what is isobar. Isotope, they are atoms of same element. That means they have same atomic number but different mass number. Isobar, they are atoms of different elements, so they have different atomic number but they have got the same mass number. Then what are isotones? Isotones are atoms of different element but they have same number of neutrons in their nucleus. So here 20 calcium 40 and 19 potassium 13. So you can calculate the number of neutron here. So atomic number is 20. So number of neutron will be 40 minus 20. It will be 20. So there are 20 neutrons here. And here atomic number is 39. Mass number is, atomic number is 19. Mass number is 39. So it should be written as potassium K. Oh, sorry, this is sulfur. Okay. So this one I am discussing. So here again, so here we discussed there are 20 neutrons. Here there are also 20 neutrons. So these two represent isotone. Here again 15 phosphorus 31 and 16 sulfur 32. So atomic number 15, mass number will be, number of neutron will be mass number minus atomic number. It will be 31 minus 15, that is 16. Here it is atomic number is 16, mass number is 32. So number of neutron will be 32 minus 16, that is 16. So this pair of isotopes, this pair of atoms, they're atom of different element, but they have same number of neutrons. So they are called isotope. Similarly, 20 calcium 40 and 19 potassium 39, they're atoms of different element, but they have same number of neutrons in their nucleus. So they are called isotope. So three important terms: isotope, isobar, and isotope. So I hope this is clear to you. This is not so difficult. It is easy. Okay. Now we will go to an important discovery, an important explanation of what we call photoelectric effect. And this photoelectric effect, it was discovered by Hertz, and he could not explain the phenomenon properly. And it was left upon Albert Einstein, the famous physicist, who explained photoelectric effect. I guess it is in 1905. He explained photoelectric effect with the help of Planck's quantum theory. So before proceeding to Albert Einstein's explanation, or simply Einstein's explanation of photoelectric effect, let us first discuss what is photoelectric effect. So here you can see a simple diagram. So this is a glass bulb, and this is a metal plate. This is a metal plate, and this is another metal detector, and it is connected to a battery, and there is a ampere meter which can detect the flow of current. Okay. Now what they observe, Hertz, they observe that when light having suitable wavelength, mind it, I am using light having suitable wavelength. That means all light do not the capacity, or they do not have the capacity to exhibit photoelectric effect. So when light falls upon the surface of certain metals, again, not all metals have the capacity to exhibit photoelectric effect. So two things must be clear: that light, it must have suitable wavelength, and the metal must be also a suitable metal, because all metal does not exhibit photoelectric effect. Otherwise, sunlight is falling in our tin roof. If tin exhibit photoelectric effect, then there would have been no question of buying electricity, because the electrons emitted from tin can be captured and it can be used to run our electrical appliances. So what I want to tell you, so what is photoelectric effect? That when light, here I am showing you light, it falls upon the surface of certain metal, then electrons are ejected from the metal surface. So this is light. It is falling upon the surface of a metal, and in return, electrons are ejected from the metal surface. And this phenomenon is called photoelectric effect. Why it is called photoelectric effect? Because the phenomenon is exhibited by light, and we already know that light is made up of energy packet called photons. So the word photo comes from photon, and when photon strikes a metal plate, then electrons are ejected. So the photon striking metal plate, and in return electrons are ejected from the surface of the metal. So these two words are combined, photon and electron. So it is called the photoelectric effect. So again, I want to repeat, what is photoelectric effect? So this is an experimental setup. So when light having suitable wavelength falls upon the surface of a metal, then electrons are ejected from the metal surface, and these ejected electrons are called photoelectrons, and the phenomenon is called photoelectric effect. And if we cut off this light, if no light falls upon the metal surface, then there will be no deflection in the ampere meter, which means no electrons are ejected. So this phenomenon, it was observed by Hertz in 1887, that when light having suitable wavelength is allowed to fall upon the surface of a metal, then electrons are ejected from the metal surface, and that phenomenon is called photoelectric effect. So at that time, 1887, light was believed to be supplying energy continuously. So if this is true, then the velocity with which the photoelectron get ejected, the velocity with which the photoelectrons will leave the metal surface, it would have depended upon the intensity of light. So higher the intensity of light, more will be the velocity of the photoelectrons ejected, more will be the kinetic energy of the photoelectrons ejected. But it was not found to be so. They found that the kinetic energy of the photoelectrons ejected, that is half mv square, where v represent the velocity of the photoelectrons, or the velocity of the photoelectrons ejected from the metal surface, should have depended upon the intensity of light. But they found this was not the case. In fact, the kinetic energy of the photoelectron ejected solely depend upon the wavelength of the incident light. Low wavelength, higher velocity of the ejected photoelectron, higher kinetic energy of the ejected photoelectron, and high wavelength, low kinetic energy of the ejected photoelectron means low velocity of the ejected photoelectrons. So this was completely opposite to what it was believed regarding light. I think it is clear. Secondly, they found that, already I told you that not all light is able to eject photoelectron. So to eject photoelectron from the surface of a metal, the light must possess a minimum wavelength. That means wavelength above it will not be able to eject photoelectron from the metal surface. So the minimum wavelength which is required to eject photoelectron from the surface of metal, that is called the threshold wavelength, and the frequency corresponding to the threshold wavelength is called the threshold frequency. So any light whose wavelength is above the threshold wavelength will not be able to eject any photoelectrons from the surface of matter. And if the wavelength of the incident light is less than the threshold wavelength, then photoelectrons will be ejected with definite kinetic energy. And lower the wavelength of the incident light, higher will be the kinetic energy, or higher will be the velocity of the ejected photoelectron. So two things that could not explain. One, that the velocity of photoelectron does not depend upon the intensity of the incident light. In fact, it depends upon the wavelength of the incident light. Secondly, they found that for photoelectron to be ejected from the metal surface, light should possess certain minimum wavelength, which is called the threshold wavelength, and the frequency corresponding to threshold wavelength is called the threshold frequency. So light having wavelength less than threshold wavelength will be able to eject photoelectron, but light with wavelength higher than threshold wavelength will not be able to eject photoelectrons. Similarly, light having frequency less than threshold frequency will not be able to eject any photoelectron, and light having frequency higher than the threshold frequency will eject photoelectron with definite kinetic energy. So these observations could not be explained by the people of that time. So it was left upon Einstein, Albert Einstein. So during that time, 1901, Planck, he proposed the quantum theory of radiation. In fact, I think it was in 1903, he proposed the quantum theory of radiation. And Einstein read his theory that electromagnetic radiation carries energy packets, which is called quanta, and in case of light, it is called photon. And each photon has got definite amount of energy, and the energy of the photon depend upon the frequency of incident light. So Einstein applied Planck's theory to explain photoelectric effect. And I would like to also tell you that why photoelectric effect, because it was the first experimental evidence of Planck's quantum theory. Already I told you in my previous lecture that black body radiation is a theoretical concept. There is no perfect black body in the universe, so it is completely a theoretical concept. And the first experimental evidence of Planck's quantum theory, that means Planck quantum theory is correct, it was proved through photoelectric effect, because Albert Einstein applied Planck's quantum theory to explain photoelectric effect. Now, how did he apply Planck's quantum theory to explain photoelectric effect? So here is a diagram. So this is a metal body. This is a metal plate, I say. So this is the surface of metal, and these are the electrons in the metal. Now this is light, and already quantum theory proposed that light composed of energy packets, and each energy is equal to h nu. And what is h nu? It is the photon energy. Nu is the frequency of the incident light, and h is the Planck's constant. So this is light, and it is composed of photons, and each photon has energy which is equal to h. Now, when the energy photon, when the photon of the electromagnetic radiation or photon of light, when it hit the metal surface, it transfers its entire energy to the electron. So this is the light which is coming in, and each light composed of energy photons. Suppose these are the energy photon, and this energy photon it collides with the electron somewhere here, and the entire energy of the photon is transferred to the electron. So now the electron will have energy equal to the photon energy. I think it is clear to you. Then what happens? Now the electron has got energy, and with this energy it will come to the surface of the metal, and the amount of energy which is required to come to the surface of the metal, it is called the work function, and it is also called the binding energy. So work function or binding energy, it is the minimum energy which is required by the electron to come to the metal surface. So again I repeat, the light is comprising of photons, and this photon is striking the electron, and it is completely transferring the energy of the photon, that is h mu, to the electron. And now the electron is having extra energy h mu, and with this energy a part will be used to come to the surface of the metal surface, and the energy so required will be called the photoelectric work function. And the photoelectric work function, it will depend upon the type of metal. Some metal will have low photoelectric work function, and some metal will have high photoelectric work function. So out of the total energy h mu, some amount of energy is used in the form of photoelectric work function, it is denoted by phi, to come to the metal surface. And the remaining energy out of h mu, the remaining energy will be h mu minus phi. H mu was the total energy received by the electron. Phi, it was energy spent by the electron to come to the metal surface. Then the energy left behind will be h mu minus phi, and it will be imparted as kinetic energy, and the electron will shoot from the metal surface with kinetic energy equal to h nu minus phi. So this is a very simple explanation by Einstein, that when an energy photon having energy h nu strikes an electron, then the photon will transfer its entire energy to the electron. Then out of this energy h nu, the electron will use some amount of energy equal to the work function of the metal to come to the metal surface. So the electron will spend energy equal to phi to come to the metal surface, and the rest of the energy h nu minus phi will be imparted as kinetic energy, and the electron will shoot, the photoelectron will shoot with kinetic energy equal to h nu minus phi. So this is how Einstein explained. So this is the total energy E, it is the energy of a photon, and this energy is spent in two ways. One, as a work function for the electron to come to the metal surface, and the rest of the energy is used by the electron to shoot with kinetic energy. So E is equal to work function plus kinetic energy, and phi naught, it is the work function, it is equal to h nu naught, and nu naught, it is called the threshold frequency. That is the minimum frequency which is required to eject photoelectron without imparting it any kinetic energy. And h nu, it is the energy of the photon. So E is equal to h nu, E is equal to h nu. Work function phi, it is equal to h nu naught, and the rest of the energy, it is equal to half mv squared. So this is the simple kinetic, this is the simple equation proposed by a famous Albert Einstein to explain photoelectric effect, and based upon his explanation, much later he won the Nobel Prize for Physics. So this is all about Einstein's explanation. So if the frequency of the incident light is equal to nu naught, then what will happen? H nu naught will be equal to h nu naught plus half mv squared. That means half mv squared will be equal to 0. And if nu is greater than nu naught, then the ejected photoelectron will have definite amount of kinetic energy. And if nu is less than nu naught, then what will happen? half mv square will be negative. That means no photoelectron will be ejected. So here, as the frequency of nu increases, nu naught is constant, so half mv square will increase. That means velocity of ejected photoelectron will increase. So this is what they observe, that the velocity of photoelectron ejected did not depend upon the intensity of light, it depends upon the wavelength or frequency of the incident light. So higher frequency means higher kinetic energy or higher velocity of the ejected photoelectrons. So this is a simple explanation that electromagnetic radiation comprises of energy packet called photon, and when a photon having energy h nu strikes an electron, it will transfer its entire energy to the electron, and with this energy the electron will come to the metal surface, and in this process the energy spent is equal to phi, which is called the photoelectric work function, and the rest of the energy is imparted as kinetic energy. So Einstein equated E, that is energy of the photon, is equal to work function plus kinetic energy of the photoelectron. Work function is equal to h nu naught. Nu naught is called the threshold frequency, and it is a characteristic of the metal. Different metal will have different nu naught value, and the kinetic energy of the photoelectron is given by half mv square. M represents the mass of electron, and here v naught represents the maximum velocity of the ejected photoelectron. So high frequency, high velocity of the photoelectron. So this is how Einstein explained photoelectric effect. So this was a very important happening in the beginning of the 20th century, because Planck proposed quantum theory, and with the help of quantum theory he could explain photoelectric effect, and later Einstein applied Planck's quantum theory, and he could explain the photoelectric effect, for which he was awarded the Nobel Prize of Physics much later. I think it was around 23 years later. It was in 1928 or so, something like that. He was awarded the Nobel Prize for Physics. And most of the students, when I asked them that for what Einstein got Nobel Prize, they said, "Sir, it is the theory of relativity." No, for theory of relativity, Einstein did not got any award. That is the most tragedy, because Einstein should have got the Nobel Prize, should have won the Nobel Prize not once but twice. But he won the Nobel Prize for physics only for photoelectric effect, and you can see that only in one equation he could explain photoelectric effect. So to become a great physicist, you need not do a lot of calculation. Only the thing is that, as Einstein said, that knowledge is more important, imagination is more important than knowledge. Because if you have proper imagination, then you can grasp the knowledge and you can explain the happening. So this is how photoelectric effect was explained by Einstein. And then in 1911, 1913, Niels Bohr, he was the student of Rutherford. He again revolutionized physics. He proposed the famous Bohr's theory to explain the structure of atom and also the hydrogen spectrum. So 1913, Niels Bohr, he studied under Rutherford at Victoria University in Manchester. So he was the student of Rutherford, and he refined Rutherford's idea. So according to Rutherford, you must have still in your mind that Rutherford's nuclear model of atom, he spoke of the nucleus, that atom has a heavy positively charged body called nucleus, and around the nucleus the atoms revolve around. But Niels Bohr, he suggested that electrons around the nucleus do not travel as they wish. They travel around the nucleus only in some selected circular path called nucleus. So if you study the planet system, if you study the solar system, we have the sun, we can consider it to be the nucleus. And the different planets, starting from Mercury, etc., Venus, Earth, Mars, Jupiter, Saturn, Pluto, etc., they are revolving around the sun and they have got their own path, and this own path are called orbit. So Bohr used that word orbit, and he proposed that unlike Rutherford's nuclear model of atom, that electrons move around the nucleus, Bohr proposed that electrons move around the nucleus only in some selected circular path, which he called orbit, similar to the planets evolving around the sun. So I think, my students, this is clear to you, the basic difference between Rutherford's nuclear model of atom and Bohr's atomic theory, that Bohr used the word orbit to define the path of electron around the nucleus, and he put some restriction regarding the movement of electron, and he used the word orbit. And what are orbit? These are selected or specified circular path around the nucleus in which the electron can revolve around. And it was similar to the planets revolving in their own orbit around the sun. Now, why did Niels Bohr has to redefine Rutherford's model of atom? Because there was a problem. This is the problem. So this is the nucleus. It is a positively charged. And Rutherford proposed that the electron revolve around the nucleus like this. But that time it was suggested by physicists, by the theory of electrodynamics, that is the movement of electron around the positively charged body. So when an electron having certain velocity revolves around the nucleus, then the theory of electrodynamics suggests that this electron will continuously lose energy. It will continuously lose energy, and it will become weaker, and it will be pulled by the nucleus, and consequently the radius of the orbit will collapse, and the electron, instead of moving around the nucleus, it will move around a circular path, along a spiral path, and finally the electron will fall into the nucleus. So this is the main drawback of Rutherford's nuclear model. That means if you go along with the nuclear model of atom proposed by Rutherford, instead of electron revolving around the nucleus, it will continuously lose energy, it will follow a spiral path, and it will fall into the nucleus. And as a result, such atom will be highly unstable. And since the electron is continuously losing energy, so we expect a continuous spectrum for hydrogen atom, but hydrogen atom gives you a line spectrum. So friends, today I have discussed an important theory or important explanation, that is the photoelectric effect. And this photoelectric effect was explained by Albert Einstein. It was explained by Albert Einstein based upon the Planck's quantum theory. So Planck proposed that light contains energy photons, and according to Planck, light is made up of energy capsules or energy packet called photons or quanta. And Albert Einstein extended this Planck's theory and he applied to photoelectric effect. And according to Einstein, photoelectric effect is due to elastic collision between photons of electromagnetic radiation or light and electrons present in the metal. So when the photon strikes the electron, it will transfer its energy to the electron, and with this energy, the electron will come to the metal surface, and in this process, it will spend energy equal to the work function, and the rest of energy is imparted to the electron as kinetic energy. Then, based upon Planck's quantum theory, Niels Bohr, he proposed the Bohr's atomic theory. Because Rutherford's nuclear model of atom was unsatisfactory, it was not accepted by the physicists, because from the theory of electrodynamics, if an electron revolves around the nucleus, then continuously it will lose energy and it will follow a spiral path and it will fall into the nucleus. And such an atom is highly unstable. And moreover, if the electron continuously lose energy, it will give you a continuous spectrum. But for hydrogen, it was found that it gave a line spectrum. So friends, in next class, I will deal in depth of Bohr's theory and also Bohr's explanation of hydrogen atom. So today I will stop here, and with a promise that I will be soon back with the part 4 lecture of atomic structure. And if you like this video, please subscribe it, please share it, so more and more friends get updated. So till then, goodbye for me.